All right, students, here is your review for everything you need to know on your test about graphs of logs and exponents, as well as the properties of logs and exponents. Especially this little first one here, partial fraction decomposition. Okay, so what we're doing is we are trying to split this single rational into the sum of two other fractions. Right? That is our goal, is to split x plus 7 over x squared minus 4x minus 5 into the sum of two other fractions. Okay, we're going to unadd these together. So our first job is to factor this, because these are going to be your two denominators when you factor this. And it doesn't matter where you put them. So I'm going to put the x minus 5 first and the x plus 1 second. Now you can put the x plus 1 first and the x minus 5 second. It's not going to change your answers. Okay? Because x minus 5 times x plus 1 is what gives you this quadratic, right? Those are numbers that multiply to give you minus 5 and add to give minus 4, or minus 5 and positive 1. So that's why our factors are x minus 1 under this denominator and x plus 1 under b. Now our next step is to multiply by the LCD, right? The least common denominator, which is this entire quadratic. Okay, so when I multiply this term by that entire quadratic, the entire denominator cancels out and I get x plus 7. When I multiply this term by that entire quadratic, the x minus 5 cancels out and I'm left with x plus 1. And when I multiply this entire term by that quadratic, the x plus 1 cancels out and you're left with x minus 5. Okay, the shortcuts, cheater way, life hack, math hack, is just to multiply this by its opposite denominator. Okay, but the reason why it works is because you're multiplying by the LCD. And things cancel out, and that's where we begin to solve this problem. Okay, so we'll distribute like we do in Algebra 1, get rid of some parentheses here and there. Right, this stays in x plus 7. We distribute over here and get a couple of terms. Right, very casual stuff. Now we're going to get your your x terms together, and we're going to get our non-x terms together. So we're combining, I don't know if we're combining like terms, but we're definitely pulling them closer to each other. Okay, we are grouping them. So there's our ax plus bx, right? We've now grouped the x stuff together. And then we have your a minus 5b, which is your non-x stuff. So then our last step is to common factor out x from both of these terms. Okay, so I have a plus b times x plus a minus 5b. Now comes the start of the hard part. Notice on the left side we have a linear equation where x has a coefficient, of course. This has a coefficient of 1. And on the right side, this is also a linear equation, some type of a y equals mx plus b. So if these two things have to be equal, that means that the x coefficients, namely 1 and a plus b, also have to be equal. So there's a 1 inside here that's hiding, and then a plus b is the other coefficient of x. Right? Truly, if the left equation equals the right equation, then all of these things have to match up. And secondly, our numerical, or your constant on the left side, needs to be equal to the constant on the right side. So this is how we create our very own system of equations that we're going to solve. Sorry, not B5. I want to write 5B. So there's your system. 1 equals a plus b, and 7 equals a minus 5b. So now let's write it more like a system so we can solve it over here. Okay, 1 equals a plus b, 7 equals a minus 5b. So if I were to multiply my entire top thing by -1, right, that would make this a -1 and a negative a and a negative b, so that when I combine these, I will get a 0a. Okay, so that's what we're about to do. We change all the signs of your first equation to minus, -1, minus a, minus b, and now we add. -1 plus 7 is 6. Negative a plus a has been eliminated. -1 plus -5 is -6b. So we can quickly find that our b value is -1. Sweet. So now we're going to go back into our 1 equals a plus b. And I'm going to replace b with -1, because that's what I just found out that b was. b was -1, so I'm going to replace b with -1. And solving means I have to add 1 to both sides. 1 plus 1 is 2. So my a value is positive 2, my b value is -1. So now I can come back over here to where I started and replace a with positive 2. And replace b with -1. Okay, let's look at the graphs. So we have 2 exponential graphs and 2 log graphs. Some things to know, right? Exponential graphs always have horizontal asymptotes. Okay, they have an all real domain, but they have a range that's usually the positive values of y. Okay. In addition, the horizontal transformations happen up in your exponent, and the vertical transformations happen either after, or they could happen before your exponent. Okay. Your x-axis reflection is here, right? So if this is negative, then you have an x-axis reflection, and if your negative is up here in the x, that's a y-axis reflection, okay? And is exponential decay. So those are things you need to know about exponential graphs. So let's see what's going on here with number 2. The x plus 3 up in your exponent, that moves our graph 3 units to the left. 3 units to the left. I know I made a very poor graph here for you. 3 units to the left is way over here. It should be the opposite way, but 3 units left. And the -4 moves our graph 4 units down. Okay, and this is the important part because your horizontal asymptote is the thing that gets moved. So now we have a horizontal asymptote through y equals -4, right? This is your horizontal asymptote, which means the range of your function is also from -4 to infinity. It always has something to do with that horizontal asymptote. Now, usually for our exponential graph, it crosses 1 unit above your horizontal asymptote, and then it, of course, grows exponentially. But that's not what ours looks like, because our point, our y-intercept point, got moved 3 units to the left. Okay, so it's going to be here. This y-intercept point is going to be at -3, -3. 3 units down, or 1 unit above your asymptote, and 3 units to the left. Okay, so that's where this point comes from. We don't worry about this point anymore. That's not a part of our graph. So our graph will start close to the asymptote on the left. It will go through that point, and it will grow exponentially, as it normally does. Okay, so a horizontal asymptote at y equals -4, a range of -4 to infinity, and that y-intercept point is 1 unit above your horizontal asymptote, like it always is, but 3 units to the left of the y-axis. Okay, let's look at number 3. So first, let's look at the 3. This 3 here in front is one of your vertical transformations. So this is been moved up 3 units. Our horizontal asymptote has been moved up 3 units, because that's what gets moved first when we do our graph. So a horizontal asymptote at y equals 3. Now the negative, this negative here means we're going to have an x-axis reflection. So where it normally grows to the up, right above the x-axis, our graph is going to be going down, which means our y-intercept is 1 unit below that horizontal asymptote. Okay, and we start close to the left, and we hit that point, and then we grow exponentially in the negative direction. So the range of this one is from negative infinity to positive 3. Right? It still has an effect on your horizontal asymptote. So the asymptote was at y equals 3, so that number is, of course, involved in your range. So those are your exponential graphs. Right? Know how to do the x and the y intercepts and where you find those negatives in your graph. So let's look at our logs. Okay, some things to remember about all logarithm graphs. Number 1, they all have vertical asymptotes. Right, so these are x equals equations, vertical asymptotes. Their range is all real values, but the domain is only positive values of x, right? It's the inverse of an exponential. So of course their x's and their y's are switched. So all logarithms have vertical asymptotes. All exponentials have horizontals. So when we do this x minus 4, and it moves our graph 4 units to the right, that means I am moving my vertical asymptote 4 units to the right, and I draw it in to begin with. You always draw your vertical asymptote. So this has a vertical asymptote at x equals 4. Okay? Vertical asymptotes have x equals equations. And then my logarithm always starts 1 unit to the right of my vertical asymptote. So my x-intercept is there at 5, 0, 1 unit to the right of my vertical asymptote. So my graph starts close to the asymptote on the left, it goes through that point, and then it grows logarithmically. So when we want to find the domain, we take everything in the parenthesis and we make it bigger than 0, because you can't take the log of a negative. Your calculator can't do it. It is undefined. So we've got to make sure that anything we plug in has to be positive. So you take your x minus 4, set it bigger than 0, and we solve this equation for x. So x has to be greater than 4, which is 4 to infinity as an interval. So the domain of this graph of this is from 4 to infinity. And it has a vertical asymptote at x equals 4. Now over here, right here we have some more going on. First of all, we're going to rewrite your inner parenthesis as the negative of x minus 2. Okay, in order to get the movement right, we need to have this in parentheses with a positive value of x. Okay, so you factor out the negative, and now we can tell from our observations that this graph will go 2 units to the right. Okay, when x is positive, your operation is a liar, right? It's the opposite. And when x is negative, this is true, so this goes to the right. Right 2 units, and then the plus 3 moves it up 3 units. So first of all, we're going to put that in. Our vertical asymptote is 2 units to the right. So we have your vertically dashed line through x equals positive 2. Okay, vertical asymptote at x equals 2. Now this 3 up business, okay, that is going to be your x-intercept point has been moved 3 units up from where it normally is. So normally it's once again 1 unit away from your asymptote. But because your x is negative, we should know that the graph is going to open to the left. Whenever x is negative, for a log, the graph opens left, which means your x-intercept point is going to be 1 unit to the left of your asymptote, because your graph will start close to positive 2 and it will go through that point and it will open up to the left. Okay, so if you're not sure about which way the graph opens, let's go ahead and find the domain. And the domain is found by taking everything in your parentheses, negative x plus 2, and making sure it's greater than 0. Because you can't take the log of a negative. So let's solve this for x. So we'll subtract 2 from both sides. Negative x is greater than negative 2. And divide by negative 1. And what happens to the inequality when you divide by a negative? It flips. So x has to be less than positive 2. If x is less than positive 2, the graph opens to the left. So it's negative infinity to positive 2 is your domain. Okay, if x is less than 2, that means your graph opens to the left. So hopefully this is a pretty good reminder of how we sketch and graph exponentials and logarithms, as well as a little thing about partial fraction decomposition.